Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, so today we're going to start chapter 10. We're going to look at section 10.1. And we're going to talk about two things, the square root property and completing the square. First of all, let's go back in time to chapter 6. If we had an equation like this, x squared minus 9 equals 0, we would say, oh, that's a second degree equation in standard form, and we could factor it as the difference of two squares, like that. And then we'd take each factor and set it equal to 0, like that. And then we'd solve each first degree equation. So we get x is -3, and we'd get x is +3. So we'd get two solutions to a second degree equation, right? So that's what we did back in chapter 6. Now we're going to look at some different ways of solving a second degree equation, depending on the situation. So let's go back to x squared minus 9 equals 0. And let's do the following with it. Let's write it so that on one side of the equation, we have a square that contains the variable. So I'm going to say variable inside. And then on the other side, we have a constant. So a number. So basically, for this problem, we would add 9 to both sides of the equation, and we'd get this. Now, in chapter 9 that we just completed, we looked at equations with radicals where we would square or cube both sides of the equation. Now we're going to go the other way. We're going to take the square root of both sides of the equation. So I get the square root of x squared equals the square root of 9. So x equals 3. However, we know from doing it this way that there are in fact two answers. X is -3 and x is +3. So when we take the square root of both sides of the equation, we put a little plus minus outside of the radical. So basically x equals plus or minus 3 is how we say that. We could also write it separately by doing it like that. Say x equals -3, x equals 3. Okay, but there are, again, two solutions to a second degree equation. This process of taking the square root of both sides is called the square root property. Again, we get it in this form, and then we take the square root of both sides, applying a plus or minus to the side that had the constant on it. Let's look at some more examples of this situation. Let's say we have the following. T squared minus 11 equals 0. So the first thing we would do is add 11 to both sides. So now we get t squared equals 11. So now it's in the form we want. We'll take the square root of both sides, applying the plus or minus to the right side. So we get t equals plus or minus the square root of 11. So t equals the square root of 11 or negative the square root of 11. I can put the plus sign in front of it, but it's not necessary. Having it blank is the same thing, right? Any questions about that example? Okay.
No.
Let's take a look at another one. X squared minus 101 equals 0. So again, I'm going to add to this. In this case, I'm going to add 101 to both sides. So now I've got x squared equals 101. Take the square root of both sides. Don't forget the plus or minus. And 101 doesn't have any perfect square factors. So basically x equals the square root of 101. X equals negative square root of 101. Now, WebAssign doesn't use this notation when you're putting answers into the equation. They'll have some multiple choice questions where you can choose an answer that will have this, but more or less in WebAssign, you need to write them out as separate answers. Okay. All right. Let's take a look at this one. U squared minus 24 equals 0. So we're going to add 24 to both sides of the equation. So we now have a perfect square on the left containing a variable and a constant on the right. We'll take the square root of both sides. So we get u equals plus or minus the square root of 24. However, we have learned from chapter 9 how to simplify the square root of 24, which would be 2 square roots of 6. So u equals plus or minus 2 square roots of 6. U equals negative 2 square roots of 6, comma, 2 square roots of 6. Okay. So we take this a step further to simplify the radical. Any questions there? All right. Let's take a look at this one. 5x squared minus 49 equals 0. So I'm going to add 49 to both sides of the equation. 5x squared equals 49. I don't have a perfect square on the left because 5 is not a square. So I'll divide both sides by 5. So I've got x squared equals 49/5. Now I'm going to take the square root of both sides. So I get x equals plus or minus the square root of 49/5. But that's plus or minus the square root of 49 over the square root of 5, which is plus or minus 7 over the square root of 5 because the square root of 49 is 7. But in the last chapter, we learned how to rationalize the denominator. So we'll do that. So we get plus or minus 7 square roots of 5 over 5. So basically x is negative 7 square roots of 5 over 5, comma, 7 square roots of 5 over 5. And so there we've got our final answers. I'll pause there for a second for you to get caught up writing that. Let me know when you're good to go on, and we will go on.
Ready.
All righty. Let's see. Let's say we've got this situation. X minus 1, the quantity squared, equals 4. Well, again, we have a perfect square on the left side of the equation that contains a variable and a constant on the right side. So it's all good to go. So we'll take the square root of both sides. On the left side, we get x minus 1. On the right side, we get plus or minus the square root of 4, which is 2. So x minus 1 equals plus or minus 2. However, we haven't isolated x yet. So we'll come back and we'll add 1. So now x equals 1 plus or minus 2. So x equals 1 plus 2, which is 3, or x equals 1 minus 2, which is negative 1. So x equals 3, x equals negative 1. There's your two solutions. Any question about that? All right. Let's take a look at another one. X minus 7, the quantity squared, equals 9. This again is already in the form we want. We have a perfect square trinomial on the left and a constant on the right. So we'll take the square root of both sides. So we get x minus 7 equals plus or minus 3, the square root of 9 being 3. Then we'll add, oops, I wanted to write that in red. Doesn't really matter, but we'll add 7 to both sides. So x equals 7 plus or minus 3. So x equals 7 plus 3, which is 10. x equals 7 minus 3, which is 4. So x equals 10, x equals 4. Those are your two solutions. All right, any questions there? Now, we're going to look at a process called completing the square, okay? And here's the deal. Let's say we have this expression. So we have the variable squared and then the variable of first degree term, okay? We want to take this expression and turn it into a perfect square trinomial. What we're going to do, note first of all that the leading coefficient is a 1, all right? That's important. The coefficient of the middle term, in this case, is 24. What we're going to do, we're going to take the coefficient of the middle term, we're going to cut it in half, and then we're going to square it. So we took the 24, we cut it in half, divided it by 2, or multiplied it by 1/2, and then squared the result. We're going to add that to what we have, and now we have a perfect square trinomial. So by taking the coefficient of x, cutting it in half or dividing it by 2, squaring the results, and adding it to the end, we have created a perfect square trinomial. Are you okay with what we just did there?
Yes.
All right. Let's see here. Where did I get that? Let's do this again. Let's say I've got y squared minus 18 squared. So I'm going to take the coefficient of y, divide it by 2, and square it, and add that to the end to make it into a perfect square trinomial. I want to point out that the number that's here, that's being squared, is also the same number that's going to show up there, complete with the sign. And also show up there, okay? We're good to go on to another example?
Yes.
All right. A squared minus 7a. So we'll take -7, divide it by 2. So we get what? -7/2. We'll square that, which gives us positive 49/4, and we'll add that to both to the binomial to make it into a trinomial, and it's a perfect square trinomial that looks like that. Are we okay with that? Any questions there?
No, I think I'm good. What you did is just square the 4, right? To get 2, the bottom, and
Square the
7.
2 to get 4. Yeah.
Yeah. Mhm,
Square
okay.
the -7 to get 49.
Yeah. Okay.
Yeah.
Thank you.
Okay. Here's another one. X squared plus 2/3 x. All right. So I'm going to take the coefficient of x and divide it by 2, okay, which is the same thing as multiplying it by 1/2. So half of 2/3 is 1/3. Then I'm going to take the results and square it and add that up here to the binomial to make it into a perfect square trinomial, whose factors would be that. So you could write it like that. Ah. We okay with that?
Yes.
All right. How about this one? N squared minus 5/3 n. So I'm going to take negative 5/3, divide it by 2, or multiply it by 1/2. I get negative 5/6. I'm going to square the results. That gives me a positive 25 over 36, because negative 5 times negative 5 on top is 25, and positive 6 times positive 6 is 36 in the denominator. So now I'm going to add 25 over 36, and I get n minus 5/6 times n minus 5/6, or n minus 5/6, the quantity squared. You okay with that?
Yes.
Now let's go back a ways. Let's see here. Where do I want it? Here. Here. Notice in this problem, we had a perfect square trinomial on the left side of the equation and a constant on the right, and then we took the square root of both sides. So what we've been looking at these last few examples is how to create a perfect square trinomial on the left side of the equation. Now, we just added a number to the end of the given original binomials, but suppose we have an equation to start with. X squared minus 4x minus 2 equals 0. We want to create a perfect square trinomial on the left side of the equation and have a constant on the right side of the equation. All right. Now, in all those examples we just did, the leading coefficient of the squared term was a 1. Okay, which it is here. So that's good. What I'm going to do, since that's got a leading coefficient of a 1, I'm going to move the constant term to the other side of the equation. Okay, and I'm going to leave a gap on the left side because I'm going to be adding a number there like we just did. So I haven't changed the value of anything, right? I just moved the constant to the right. So now I'm going to take the coefficient of x, which is a negative 4, cut it in half, which gives me negative 2, square the results, which gives me a positive 4, and add it to the left to create a perfect square trinomial. But because this is an equation, since I'm adding 4 to the left side of the equation, I must also add 4 to the right side of the equation. So now I've got x squared minus 4x plus 4 equals 6. So far, so good?
Yes.
On the left side of the equation, I have a perfect square trinomial. On the right side of the equation, I have a constant. So now it's in the form of a perfect square trinomial equals a constant, which is what I want so that I can go to the next step, which is to take the square root of both sides. So I get x minus 2 equals plus or minus the square root of 6. Then I add 2 to both sides and I get x equals 2 plus or minus the square root of 6. You okay with that?
Can you explain the last steps?
So from here?
Yes.
All right, so what I did there, same thing I did earlier on some problems, I needed to get x by itself. And since it had x minus 2, I had to add 2 to both sides.
Okay.
But I can't combine these because they're not like radicals. 2 and the square root of 6 aren't compatible.
Okay.
So I've got x equals 2 plus the square root of 6, x equals 2 minus the square root of 6. And again, on paper, you can use this notation. But in WebAssign, you'd have to put them in separately. The 2 plus the square root of 6, the 2 minus the square root of 6, okay? Now, I want to take those two solutions and go to the next page. Because we're going to do an additional thing to these using a calculator. If you don't have a calculator handy, don't worry about it, but you'll need to use it when you're doing this assignment. It says, approximate each solution to the nearest hundredth. So on my calculator, I put in 2 plus the square root of 6, and I get 4.449489743. But it said round to the nearest hundredth, which would be right there. The 9 would round up, so I get 4.45 as my first answer. Okay. Then I'm going to go back and put in 2 minus the square root of 6, and I get negative 0.449489743. And to the nearest hundredth, that would be negative 0.45. So I get those two answers. Any questions about that?
No.
All right, let's do another one. Let's see here. T squared plus 22t plus 93 equals 0. So I have a leading coefficient of a 1. That's good. But I need to move the constant term over. So I'm going to subtract 93. Wait a second. Yeah. Okay. Subtract 93 from both sides of the equation. I guess I better just leave my glasses on. So now I've got t squared plus 22t equals negative 93. Okay. My coefficient of t is 22. Divided by 2 is 11. Squared is 121. So I'm going to add 121 to both sides of the equation. On the left side, I now have a perfect square trinomial. On the right side, I have what, 28? Negative 93 plus 121 would be 28. So on the left side, I have t plus 11, the quantity squared, and on the right side, 28. Are you okay with that?
Yes.
So now we'll take the square root of both sides of the equation. On the left side, I get t plus 11. On the right side, I can take the square root of 28 and write it as the square root of 4 times 7. The square root of 4 is a 2 outside, so I get plus or minus 2 square roots of 7. But I'm not done because I still have t plus 11. So I'm going to subtract 11 from both sides, and I get t equals negative 11 plus or minus 2 square roots of 7. So t equals negative 11 plus 2 square roots of 7. T equals negative 11 minus 2 square roots of 7. So those are the two exact answers. And in a minute, I'm going to rewrite those on the next page, and we'll put them into the calculator to get decimal approximations. Are we ready to go on to do that, or are you still writing?
Ready.
Okay, t equals negative 11. Let's see here, where did it go? Plus 2 square roots of 7, negative 11 minus 2 square roots of 7. So let's see here. negative 11 plus 2 times the square root of 7. So I've got negative 11 plus 2 square roots of 7. And I get negative 5.7084, etc. Rounding to the nearest hundredth, that would be the 0. The 8 would round up. So negative 5.71 would be the first answer. And then the negative 11 minus 2 square roots of 7, not 17, sorry, 7 would be negative 16.2915. So negative 16.29. Again, because the 1 here would round down in the thousandth column. Okay with that?
Yes.
All right. Now, we've been looking at problems where the leading coefficient had was a 2, was a 1. Now it's not going to be a 1. It's going to be something else. Okay. So what we need to do is make that leading coefficient a 1. So our first move is going to be to divide everybody by whatever that number is. So now I've got x squared minus 5/2 x plus 1 equals 0. Okay, so the first step, let's say we think of it as ax squared plus bx plus c equals 0. If a is something other than 1, you divide everybody by a so that now your leading coefficient is a 1. All right.
Yes.
Next move the constant over. So now we're back to what we did before. I left a space to put that number that I'm going to add to both sides. So I take the coefficient of x, I divide it by 2 or multiply it by 1/2, so I get negative 5/4. I square that, which gives me 25/16, and I add that to both sides of the equation. Having done that, on the left side of the equation, I have perfect square trinomial. On the right side of the equation, let's see, negative 1 plus 25/16. Our common denominator would be 16. So negative 1 times 16 over 16 would be negative 16/16 plus 25/16, which is what? 9/16. So all that, now I've completed the square and I have it in the form to use the square root property. I have a perfect square trinomial on one side and a constant on the other. Before we go on, any questions about any of the steps?
No.
All right, so I'm going to take my bottom line there and take the square root of both sides. And 5/4 9/16. So I get x minus 5/4 equals plus or minus. The square root of 9 is 3. The square root of 16 is 4. So I get plus or minus 3/4. Then I'm going to add 5/4 to both sides. So x equals 5/4 plus or minus 3/4. X equals 5/4 plus 3/4 would be 8/4 or 2. X equals 5/4 minus 3/4, which would be 2/4 or 1/2. So x equals 2 and x equals 1/2 would be the final two answers. Good to go with that?
Yes.
All right, here comes another one. 5m squared plus 13m minus 6 equals 0. We don't have a leading coefficient of a 1. So the first thing we're going to do is divide everybody by the coefficient, the leading coefficient, so that we do have a leading coefficient of a 1. Okay. The next thing we're going to do is move the constant to the other side of the equation. So we'll add 6/5 to both sides. Then we'll take the coefficient of m, cut it in half or multiply it by 1/2, or either divide by 2 or multiply by 1/2. So we get 13/10. Square the results, we get 169/100, which we add to both sides of the equation. And I'll pause there for you to catch up.
Ready.
All right. So now I can combine the two fractions on the right side, and the left side is a perfect square. So I've got m plus 13/10 times m plus 13/10, or m plus 13/10 squared. My common denominator of 5 and 100 is 100. So 6/5 I'm going to multiply by 20/20 to get 120/100 plus 169/100, which gives me 289/100. So now I've got it in a form where I've completed the square. I can apply the square root property. So let me know when you're to this point. I'm going to take that and go to the next page.
I'm ready.
All righty, so we've got m plus 13/10 squared equals 289/100. We're going to take the square root of both sides. So we get m plus 13/10 equals plus or minus, let's see, the square root of 289. See if that comes out nicely. 289 is 17, and the square root of 100 is 10. So I've got that. So then my next move is going to be to subtract 13/10. So I've got m equals negative 13/10 plus or minus 17/10. Okay. So m equals negative 13/10 plus 17/10, which is 4/10, which is 2/5. Or m is negative 13/10 minus 17/10, which is negative 30/10 or negative 3. So m is 2/5, m is negative 3. Those would be your two solutions. All righty.
Got it.
All right. Let's take this one. 6x squared minus 12x plus 1 equals 0. We're going to complete the square, get an exact solution, and then get an approximation to the nearest hundredth. So the leading coefficient is not a 1. Oh, and I should point out it's in standard form, x squared, x constant. Okay, we're going to divide everybody by 6. So we now have x squared minus 2x plus 1/6 equals 0. Then we're going to move the constant over. We'll subtract 1/6 from both sides. X squared minus 2x equals negative 1/6. And again, it's important to leave a space here because I'm going to be adding a number there as well as over there. Coefficient of x is -2. Divide it by 2, you get -1. Square it, you get +1. So we're going to add 1 to both sides. On the left side, I have x minus 1 times x minus 1, or x minus 1, the quantity squared. On the right side, my common denominator is 6, so I've got -1/6 plus how many sixths? Well, I'd take 1 and multiply it by 6/6, so I get -1/6 plus 6/6, which is 5/6. So now it's in the form of a perfect square trinomial equal to a constant number. I'm going to rewrite that on the next page. When you're ready, let me know.
Ready.
All righty. So we've got x minus 1 squared equals 5/6. So we'll take the square root of both sides. I get x minus 1 equals plus or minus the square root of 5 over the square root of 6. I need to rationalize the denominator, so I'll multiply by the square root of 6 over the square root of 6. So I've got x minus 1 equals plus or minus the square root of 30 over 6. Okay. Then I'm going to add 1 to both sides. So I've got x equals 1 plus or minus the square root of 30 all over 6. Now, you can leave your answer like that, or what they'll sometimes do is they like to write it as a single fraction. So you say, well, the common denominator is 6. So I'm going to take the 1 and write it 6/6. So then I've got 6 plus or minus the square root of 30 all over 6. So again, I want to point out this answer is correct. So is this one. I'm going to take this and write the two separate answers and go to my calculator. Now, if I choose to put this in my calculator, I need to quantify the numerator. So I'm going to put in 6 plus the square root of 30, and there's probably going to be a set of parentheses around the 30 inside the radical, and then divided by 6. So you've got to quantify the whole numerator inside parentheses, as well as quantify the radical. Okay, so I've actually got two sets of parentheses. So I'm going to have left-hand parenthesis 6 plus second square root, which gives me the square root symbol in a left-hand parenthesis. I'll put in a 30, close up that inside set, close up the outside set divided by 6. And I get 1.9128, which would be 1.91 rounded to the nearest hundredth. I don't know if you can see this or not. See how I've got two sets of parentheses? Can you see that?
No, it's very blurry.
Okay, well, you can see on my whiteboard. Let me.
Yeah.
So let me do this. 6 plus the square root of 30 over 6. On your calculator, you'd put a left-hand parentheses, then 6 plus the square root of 30, and you've got that set of parentheses that's around the radical, and then you're going to close up the whole thing divided by 6. So you've got the black set and the blue set. The black set of parentheses, that's the radicand inside the radical. The blue set of parentheses is so that the whole numerator is divided by 6. Because if you do this, that's like this. And you don't want that. You want that. So you've got to tell the calculator that the whole numerator is being divided by 6. Okay. And then back here, the second one, you'd have, again, 6 minus the square root of 30. That whole thing divided by 6. And that comes out 0.087, and rounding that would be 0.09. So you get those two solutions. All righty. So two new things: the square root property, where you get a perfect square trinomial on one side equals a constant on the other. You take the square to both sides, you apply a plus or minus to the right side that has the constant. And then completing the square, where you have an equation and you put it in the form of a perfect square equals a constant, and then apply the square root property. That's all I have for today. I'll be back at 1:15 with an office hour.